Hi everyone. Today I want to review with you the properties of integer exponents. We did the investigation in which we looked at how we use exponents, and now I just want to review the rules with you. So, the first one, products of powers. So again, remember, when you have the same base, and I'm going to multiply those bases, I want to add the exponents. And then notice your little example there, 2 to the third, 3 2s, 2 to the fourth, 4 2s. Well, I'm just multiplying 2 times 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 7th power. So my rule is any base raised to the m power times a to the nth power will equal a to the m plus n. I want you to make sure you write down both of these next examples. The first one is going to use variables, and then the second one I'm going to use numbers. So, n to the fourth times n to the fifth equals, same base, fourth power, fifth power. That will give me n to the ninth power. Now, using numbers, 5 to the third times 5 to the second, well, again, I have 5 3s, I have 3 5s, I have 2 5s, which will give me 5 to the 5th power. So again, when I multiply powers having the same base, I simply add the exponents. Now, on the next one, it's the power of a product. To find the power of a product, and this is different than the previous one because that has the same base. These are going to be different bases. Find the power of each factor and multiply. So again, if you look at it broken down, 2 times 3 to the third power. Well, that would be the quantity 2 times 3 times 2 times 3 times 2 times 3. Multiplication, I can remove those parentheses. It won't change anything. Write it out without the parentheses. Notice I have 1 2 3 2s, and I have 1 2 3 3s. So 2 to the third power times 3 to the third power. So when I look at that as the rule, I would do this a to the m power times b to the m power. So I have 2 factors and the exponent. Now again, using variables and numbers, let's say that I'm going to multiply m times n, and I'm going to raise that to the 6th power. Well, that's going to be the same as m to the 6th times n to the 6th. Using numbers, 4 times 6 raised to the 4th power, 4 to the 4th power times 6 to the 4th power. So notice the difference between products of powers. I have the same base. Power of a product, my bases are different. They're factors. Then the next rule, and again this one's still going to work with multiplication, this is a power of a power. So to find a power of a power, I'm going to multiply the exponents. And here again, if you look at the example kind of broken down, 2 to the third to the fourth, well, 2 to the third times 2 to the third times 2 to the third times 2 to the third. Okay, then write it out. 3 2s, 3 2s, 3 2s, 3 2s. Well, count them all up, and I have 12. So now my rule is when I take a to the mth power, and I raise that to the n power, that's the same as a to the m times n. Now using variables and numbers, again, n to the third power, and let's raise it to the 4th power. Notice I multiply the exponents. So this would be n to the 12th power, and if I use numbers, 7 to the 5th power raised to the 4th power, well, again, 5 times 4 is 20. 7 to the 20th power. Okay. Now, make sure you notice the difference between these three. These three rules refer to multiplication. So, on my very first one, same base. They were just raised to a different power. On the second one, different bases, but they were raised to the same power. And then on this one, it's the same base, but that base is raised to a power. Notice that it's in parentheses and then it's raised to another power. So just be careful when you're looking at those. Now, the next two rules are going to work with division. So if you kind of remember that multiplication and division are related, if I'm going to be adding when I multiply, well, when I get to division, what I'm going to do is subtract. So let's talk about powers, quotient of a power. When I'm going to divide powers and I have the same base, well, I'm going to subtract my exponents. And again, if you notice the example which breaks it down for you, 2 to the 5th, 5 2's, 2 to the 3rd, I have 3 2's. Well, if I divide 2 by 2, that's going to give me 1. 2 divided by 2 is 1. 2 divided by 2 is 1, which leaves me with 2 times 2, and then I have 3 1's, which is 2 times 2, which is the same as 2 to the 2nd power. So when I have a division problem, this would be a to the m minus n. And again, when I use numbers or variables, y to the 4th divided by y. Now remember, any time I have a variable by itself, my exponent is 1, so we do still subtract. 4 minus 1 is 3, so that would be y to the 3rd. And then using numbers, 3 to the 4th divided by 3 to the 2nd, subtract 4 and 2, that's going to give you 3 to the 2nd. And then, similar to the power of a product, I have a power of a quotient. So this time, notice that my bases are the number, that's a 2 and a 3, whereas on this previous one, it was the same base. So now I'm going to raise that to the 4th power. So what I'm going to do with the power of a quotient, to find the power of the numerator and the power of the denominator, and then I can go through and divide those. So 2 to the 4th, 4 2's, 4 3's, combine them, 2 to the 4th divided by 3 to the 4th. So again, when I do this, this would be a to the m power over b to the m power. And if I put variables and numbers again, let's say x divided by y to the 5th power, that would be the same as x to the 5th power over y to the 5th power. And then if I use numbers, so let's use 7 and 7 divided by 10, raise it to the 6th power, that would be 7 to the 6th power over 10 to the 6th power. Okay. And it's very similar to when we did the power of a product, only this time, because we have a division bar there, it's power of quotient. Okay, the last two then exponent rules. The first one is going to work with when I have a base that is raised to the 0 power. So if you look at the problem that's listed here, I have 2 to the 3rd power divided by 2 to the 3rd power. If I go back up and look at my rule for division, I know that I would subtract. So 2 to the 3rd power minus the 3 would give me 2 to the 0 power. 2 to the 0 power is equal to 1. Another way to show that is bring all my 2's, show all my 2's in the denominator. Well, those would all cancel out in 1. So any number raised to the 0 power, any variable raised to the 0 power is 1. And 9 to the 0 power equals 1. N to the 0 power equals 1. So any number raised to the 0 power is 1. And then finally, our last rule is going to deal with negatives. So any negative exponent means take the reciprocal and then take the power. Now, an easy way to say that is when we look at negative exponents, just remember that a negative exponent is a fraction. It's not a negative number, it's a fraction. So, for example, if I did 2 to the 3rd power over 2 to the 5th power, that would be the same as 2 to 3 minus 5. Well, when I do that subtraction, I get a negative number, so that's 2 to the negative 2nd power. Well, if I actually write it out, I have 3 2's, I have 6 2's, cancel those out. That's the same as 1 over 2 to the 2nd power. So a negative exponent means put 1 in the numerator, and the denominator is your power raised to that exponent. That exponent is now positive. So a to the negative m is the same as 1 over a to the m. And then again, when I do that with variables and numbers, n to the negative 5th is the same as 1 over n to the 5th. 7 to the negative 3rd, 1 over 7 to the 3rd. Most important thing you've got to remember about a negative exponent is that it doesn't mean it's a negative number. It means it's a fraction. Make sure that you fill in your Google form. If you have any questions, bring them to class tomorrow.